we've got a volume of revolution question here. We're taking the curve in C, rotating it around the y-axis to create the solid in figure 1. What this means is we take a rectangle. It's going to have height of delta y. Rotate it, and this will give me a little cylinder with radius x. So this small volume, maybe I call it delta v, would equal pi x squared, because the radius is x, times by delta y. And then I want to sum all of these together. And that's where I'm not going to go into where it comes from, but we get an integral. And the integral is going to be pi x squared with respect to y. I'm summing up all of these infinitesimal little cylinders from y equals 0 to y equals 2, because it's when x is 0, y is going to equal 2 at the very top. That's my volume. So now I can work this out. I'm going to replace the x, I can bring the pi out, replace the x squared by 2 minus y. This becomes pi 2y minus a half y squared, evaluated between 0 and 2, which is pi times 4 minus a half times 4. So we get a volume of 2 pi, about 6 meters cubed. We're actually asked to estimate the mass of the concrete. So density is mass over volume, and therefore the mass is going to be density times volume, 900 times 2 pi. This is 1800 pi, or 5654.86. Rounded to 5,700 kilograms to two significant figures. Great. Give a limitation to the model. So I went with it may not be symmetrical. That is an assumption we're making when we're doing this volume of revolution. Here's some other things you could say. It's not smooth, which we've assumed. It might not follow the shape of the curve. It won't be solid, could be gaps in it. Equation of the curves may not be a suitable model. Concrete's likely to be uneven. And then finally, the one that I put, the pile's unlikely to be symmetrical. And finally, so we're told that the mass of concrete waste is actually 5,500. Use this information in your answer to A to evaluate the model, giving a reason for your answer. So I decided to go with the percentage error, which is the error divided by the true value times 100. It's a bit like when you do a percentage increase. It's the increase divided by the original times 100. You might use multipliers instead, but you can always get to that formula. This is worth knowing. So I'm going to use my non-rounded value. I think that's best. 5654.86. And then I'm going to minus the 5,500, divide by that actual value, times by 100. So 2.8%. And I said, this is small. This is a small percentage difference. I mean, it's all relative, isn't it? But it seems quite small, so good model. Okay, here's what the mark scheme said. So it makes a comparison. You could say a 200 difference. I mean, that's using the rounded version, which is a lot of concrete, therefore not a good model. You could say it's not a good model, but you could also say it's close, and therefore is a good model. But both of these are accepted as long as you're making, a sensible conclusion. Finds the percentage error and draws a conclusion. That's the one I did. I'll just simply say the masses are close. And yeah, so don't stress about this one. Just a sensible kind of comparison and conclusion, and you'll be okay. Well done.